Observe we have a button in front that could be a push button for the public to use if this was a public display, and this thing says push and release when status light is green, and the status light is up here. You can see it's green, and when we push this button, that status light will change to red and the trains will start running. This is running just a single cycle. We can also run this continuously, but right now it's just running a single cycle. Now you can see the status light just changed back to green, so we ran and completed one cycle. Again, if this is on a display, it'll sit and wait until somebody comes along and pushes the button again and repeat itself, which we'll do now. We're using that Lionel transformer on the left for track power and switch power, and we're using an NCE power cab to power the relays that are controlling these trains. Now the system stopped again, and again it'll wait until somebody comes along and pushes the button. Now we can do one thing differently. If we want those trains to run more laps, we have the ability to increase the number of laps. Let's do that next. We'll throw this toggle switch here, which should make them run 2 laps. There's the first lap around, and there's a Z-stuff detector back by the rear switch. And when it crosses that detector, you might be able to see the light in the block went out. We've got two 35-inch long stop blocks. Now there's our first lap. And watch that green light in the block. You see it just went dark. That means the stop block turned off, and it'll stop that train coming around. So basically we've got a Z-stuff detector back in the rear by that rear turnout, and when that detector detects the train coming toward the rear turnout, it'll turn the appropriate stop block off to stop the train coming in. Now if we push that switch again, they'll again run 2 laps each, but we have another option we've got programmed here. We have a second switch for more laps, and this will produce either, I believe, 3 or 4 laps when we open that switch. And again, observe the status light's green. It will go to red in a second. Well, there's our first lap around. And there's our second lap around. Now there's our third lap around. Now again, watch when it goes across the detector back in the rear. You'll see that block turned off and it'll stop. Now the inside loop should do about the same thing. We don't have the ability with this simple system to count laps, but we can use time delays to get an approximate number of laps. There's a second loop, I believe. There's the third loop around, I believe. Now watch when that train passes in front of that detector. Well, it's still green, so I guess we're going to make another lap. Now you can see that power light went off and that train stopped. So they made another cycle, completed another cycle, and they're waiting until somebody pushes the push button again. And notice the status light's back to green, indicating we can push the push button again. Hello, I'm James Ingram for AutoControls-dot-org. In this hybrid video, we'll be using a DCC Programmable Model Train Controller, also known as an NCE Mini-Panel, to control two non-DCC conventional O-gauge locomotives. Our DCC train controller is here, and we have a relay here which controls this outer track block, and we have a second relay here which controls this inner track block. And so we can use this NCE Mini-Panel, the train controller, to control these two stop blocks, to control these two non-DCC locomotives, which in this case happen to be a pair of the Bachmann Chuggington locomotives. And the controller also controls that turnout back in the rear, which directs the trains into one of the two sidings. So via means of the two stop blocks and the turnout, we can control these non-DCC trains using a DCC programmable train control system. Now we're going to do the same thing, except we'll just run one siding at a time, which is another option we have. And as I mentioned, we can run these continuously, which we'll do in a minute, but right now we're just running single cycle. I'm going to open this toggle switch, which should take us back to 2 laps, and I'm going to open this toggle switch, which will turn off this siding, so we should just be running the inner siding in 2 laps. There's our first lap around. And you can see the block turned off there, and it trapped that train. So that was a second lap. It did 2 laps and stopped. And likewise, we can run the other train by itself. I'm going to open the switch for the inner loop and turn on the switch for the outer loop and push the button. There's the first lap around. There's a second lap. You can see the power light turned off and that train stopped. So again, they'll sit and wait there until somebody comes along and pushes the button again. Now we'll run this system again, but we'll put it in what we call continuous mode. So rather than stopping, it'll keep operating. And we'll close this switch here called the repeat switch, which is what causes it to run continuously. And we'll turn both sidings on, and we'll turn off our additional laps toggle switches. So it should just run one loop for each train, but keep going continuously. And status light's green, we push the button, status light's red. Now there's one loop of that train. Now this train will run one loop. And again, watch when it goes across the detector, that light will turn out. Now you can see it's just repeating continuously. There goes the inside loop. I just switched that red toggle switch. It says stop time. That will cause them to wait longer in the yard, so to speak. Instead of the second train starting out immediately, it'll sit about an additional 4 seconds or so. So rather than having the trains, one train stop and the other start right away, we can have both trains stop and in there sit for a minute and wait. There goes the inside loop. And notice this relay here is controlling the outer loop. And if you watch that arm, you can physically see that arm change in a second. There goes that arm shifted over toward me. That's an LGB relay, and you can actually physically see the arm moving on that. The inner loop's being controlled by an Azatrax relay, and you can't see what it's doing. You can see they're each running one loop each continuously with an extended wait time. So now let's go over there and switch them to more loops. We'll turn off the extra stop time and I'll turn off the out of track. Now it's doing just the inner loop continuously. Put the stop time back on. Now we're running just one loop continuously with an extended stop time, which is adjustable. You can see that sitting there for about an extra 4 seconds. I turned off the extra stop time. I turned on the toggle switch. It should make it run 2 laps. So you can see that train is, the red train is coming around the outside loop for its first lap. And it's going around for the second lap. And watch the block light. You can see it went off when it passed the detector, which stops that train. Now there goes our inside loop. There's the first lap on the inside loop. There's a second lap on the inside loop. There goes the outside loop. Now we'll add the additional laps. I'll open that second toggle switch that says laps, and that should make them go about 3 or 4 laps. There's the first lap around. There's the second lap around. There's a conventional Lionel transformer over there. I forgot if I said that. That's providing the track power. The DCC system is just operating the relays and controlling the turnout back in the rear, the diverging turnout. And that went either 3 or 4 laps. There's the first lap on the inside loop. Second lap on the inside loop. Third lap on the inside loop. There's the fourth lap on the inside loop. Should stop this time around. You can see that block light went off. Now we'll turn off the extra laps and we'll turn off the repeat switch. Now that train was in the middle of its little program. There it goes. Now there's the inside train. And the power light went off on the block, so that train stopped. And you can see the status light just changed back to green, which tells us the system is ready to push the button again. So we can basically run any combination of number of laps and one train or both trains that we want to. Now we've been using this Z-Stuff detector to tell us when the train is coming into the converging switch back in the rear. But as I mentioned, we can run without a detector. If you look out there on the layout, you can see the green light back in the rear, which is a Z-Stuff detector. I've moved it out into the layout where it won't detect the train. So essentially we're running with no detector. And we can do that. We just have to allow extra time to make sure the train gets back into the block and gets stopped at the stop block. With the detector, we know when the train is entering the yard where the converging switch is back in the rear, and we can normally allow about 4 seconds or so for those trains to get up onto the stop block because we know where they are. With no detector, we're kind of running blind, and if you think about it, we just run a time delay for a certain amount of time to power them, then we turn the block off, and we know eventually that train's going to come around and stop in the block. We just have to get our timing correct. The shortest time is if the train is back, say, almost by the rear switch when we turn the power off. But if the power goes off when the train is, say, right here, it's going to need the maximum amount of time to make a complete loop around. And we'll demonstrate that next. And I've turned the repeat switch on. I turned these two switches off because we're using this special routine that says no detector controlled by this switch, and I've turned the extra lap switches off. So let's push this button. Now that we've got extra time delay, you can see that green light turned on, and you can see when it turns off is when it times out. So we're just basically running the trains blind, but we're using time delay. Now if you watch that switch there, you can see it went out. If you watch that light, I mean, you can see it went out. So we know that train's going to stop whenever it gets into the block, and we wait enough time, that train will start out. And again, you can see that light went out. So that train will stop when it gets into the block. Now we can add some extra time delay to run multiple laps, as we did before. I just closed the upper lap switch, which should add some additional time. And again, we're running blind, so to speak. We don't have the detector telling us where the trains are, but if we run for a certain amount of time, which we're doing now, and then we turn the block off, which we just did, you can see it ran 2 laps. There's the first lap, and you can see the block is still green. So that means that train's going to go on through. You can see it went dark, which means the power is turned off, so that'll stop. So right now we've got it set up, we're running essentially 2 loops for each train, 2 laps, without using the detector. Notice the detector sitting back there solid green. It's not getting activated. power went out there just now. Now we'll throw the other additional lap switch. So that should run them additional laps. I think that was one loop. There's two loops. There's the third loop. There, the power went out, so that should get stopped on the fourth loop. Now we have our time delay to make sure that train got back into the stop block and stopped. Now the inside loop is running. There's the first loop. There's a second loop. There's the third loop. There's a fourth loop. Now you can see that light went off in that stop block, so this train will stop. But I turned the extra lap switch off. That one's still executing the program because it already started before I opened the switches. But and I turned off the repeat switch, so when they complete their cycle, they'll come to a stop and wait. This is our extra time delay because we're running blind. You can see that light went off, which means we'll stop. Now the repeat switch is off, so it means we're not going to run again. We've got that time delay. Now you can see the status light went back to green, which tells us we can use our push button to start the system up again. So the point is you can set this to run either with a detector or without a detector. If you had a big loop, this loop is small. If you had a big loop, running without a detector would not be as good because you'd have to allow a lot of extra time delay to make sure the train went around your big loop and got back into its stop block. So you might have a lot of dead time. So with a bigger layout, the detector would probably be more desirable. Now we're back on the rear end of the layout, and we'll demonstrate a little test routine. What we've got here is our Z-Stuff detector. This is a DZ1012 infrared block signal detector, and over here is a Z-Stuff DZ10008, I should say 1008 relay. And what happens is when something rolls in front of this, it'll block that infrared signal, and it'll change to red and close the relay. And we have the relay wired back to the Mini-Panel, which is how we know when a train is going through here. And what this test routine will do is when I roll this car in front of the detector so it turns red, it'll throw that switch, that turnout to curved, wait 2 seconds, throw it back to straight, and then it will cycle each of the two stop blocks on and off for 2 seconds, which hopefully we can see by the lights coming on. So let's try that. There you can see the detector went to red, turnout went curved straight. Now the outside siding, they're off, the inside siding on, off. This will keep repeating, turnout cycling, curve straight, outside siding on, off, inside siding on, off. And if we roll this back away, you can see that detector sets back to green, and the things stop happening. So basically this is the very first thing I hooked up when I was assembling this layout, and this kind of tells me that the detector and the turnout and the two the two relays that control the stop blocks, that everything is working as it ought to be. And let's do that again. There's the car blocks the detector, turns red, switch turnout cycles. Now you can see the stop blocks up there are cycling. Now back to the turnout, it goes to curved, then straight. Outside siding comes on, 2 seconds, turns off. Inside siding comes on for 2 seconds, turns off, and it keeps going through that cycle until we unblock the detector. Now we've got a pair of MTH Docksiders on the layout. We'll start those up. These actually work very well for running because we can get a fairly slow speed out of them, but they run very well at a slow speed like they're doing now. The disadvantage of them for this video is they're kind of noisy due to the metal, the grooves they cut in the metal tires for traction. We can run just about any pair of locomotives on this system as long as they run somewhat the same speed. If they're too much different in speed, then one's going to go real fast and one's going to go slow, since we're keeping our transformer at a fixed voltage when we run these things. And the other requirement we have is they have to start up in forward direction when you put the power to them. So you pretty much got to have something you can lock into a forward direction, which these Docksiders, you can do that. You probably couldn't use a Proto 2 or a Proto 3 locomotive because they tend to come up in neutral, and that wouldn't work on this type of a system. Now I opened the repeat switch before it completed its cycle, so you can see the status light went back to green, and they parked, and they'll stay there waiting until somebody pushes the push button again. Now we've got two streetcars on the system, and we'll demonstrate those. That green car that just went by is an MTH PCC car, and most of those seem to run too fast to run with a Bachmann Williams Peter Witt car, which is what the yellow one is. But this particular car, it's borrowed from a friend of mine, Bob Schilt. He's got 3 of them, and the other 2 run pretty fast, but this one runs slower than the other 2 for some reason, so I can run it together with the Peter Witt car. Now the yellow one that just started up, that's the Bachmann Peter Witt car. The MTH cars, like the green one, they can be locked into forward, but the Bachmann Peter Witt cars, that's like the yellow one running, they don't have any switch to lock them into the forward direction, so you're stuck with cycling the forward, neutral, reverse sequence. However, what we can do, what we have to do, if we let it sit long enough, I think it's about 15 or 20 seconds, it times out so that the next time it starts, it comes up in forward again, and that's what we're doing here. We have to run long enough with the green car that while that yellow one is sitting out there, it sits there long enough that it goes back into forward the next time it gets power, and that's how we're running that on the system. You can see the yellow one sat there long enough that when it started up again, it started up again and forward. But if I have one of the lap switches thrown for more laps, if I open that lap switch so they just run a short time, it won't work. The yellow one will, when it's supposed to start up, will sit there in neutral. But this shows a method we can use the same system to run our mass transit vehicles if we need to. Well, this brings us to the end of part 1. In part 2, we'll look at the parts list for this control unit, the wiring diagram, and also the commands used to operate the system. We should mention one more thing with regard to automatic passing sightings. This device, we didn't use it in this video, but it's a railroadconcepts.com, and I believe now you can do it without the hyphen. This is an older one, but this is a Yardmaster, and what I'm holding is an older version, but you can go on the website and see go on their website, rrconcepts.com, and see the latest information on these. But this is also meant to control automatic passing sightings without a computer, without DCC, without a Mini-Panel. So he's been making these for, I think, 30 years now, the Railroad Concepts line of stuff. But you should take a look at that if you're interested in automatic passing sightings.